The microwave sitting in your kitchen may already be obsolete, not because someone invented a faster microwave, because Japan is attacking the problem from the opposite direction. One company is teaching the microwave to see your food. Another is using superheated steam instead of conventional microwave heating. Another technology isn't even trying to heat food at all. It's trying to control what happens to the water inside your food while it freezes. And here's the part nobody sees coming. The biggest business opportunity may have almost nothing to do with selling you a new kitchen appliance. Because the companies solving these problems aren't just competing to replace your microwave. They're competing to control what could become a multi-billion-dollar food technology market. But before we get there, there is one question you've probably never asked. Why does your food have to spin? Think about it. You put a plate inside a microwave. You press a button. And the glass plate starts rotating. It feels completely normal. So normal that you've probably never wondered why it's there. But that spinning plate is actually a clue. Because it isn't really a brilliant cooking feature. It's a workaround, and once you understand what it's working around, you'll understand why Japan is attacking the microwave from 4 completely different directions. First, there is the machine that tries to measure your food instead of guessing. Then there is a technology that uses superheated steam to cook, without relying on conventional microwave heating. Then there is a system designed to give food a kind of second life through controlled steam. And finally there is the strangest one of all, a technology that doesn't heat food. It creates an electrical field that can influence how water freezes, and that final technology is where this story stops being about your kitchen, and starts becoming a business story worth billions. The problem was there from day one. To understand why this is happening, go back to the beginning. In 1945, an engineer named Percy Spencer was working with radar equipment at Raytheon. During an experiment involving a magnetron, he noticed something strange. A chocolate bar in his pocket had melted. He investigated. Then he experimented with food, popcorn, eggs, and eventually, the basic idea behind microwave cooking emerged. There is an incredible irony here. The technology that became one of the most common kitchen appliances in the world wasn't originally designed to cook food. It came from radar technology. The magnetron was designed to generate electromagnetic energy for military radar. And it was never designed around the problem that microwave engineers would eventually face. How do you distribute that energy evenly across a plate of food? That's the problem that stayed with the technology. The microwave sends energy into a metal cavity. That energy reflects around the interior. And it doesn't naturally heat every location equally. You get hot spots, you get cold spots, and sometimes you get the classic microwave experience, burning hot around the edges, while the center is still practically frozen. So engineers needed a solution. And they found one that was brilliantly simple. Move the food. The answer is embarrassing. That's what your turntable is doing. It's moving your food through different areas of the microwave cavity, so that, over time, different parts receive different amounts of energy. Instead of perfectly controlling the energy, the machine moves the food through the problem. And for decades, that was good enough. But here's the question. Japan started asking, what if you didn't need to move the food at all? What if the machine could understand what was happening inside the cavity, and control the energy instead? That's where the first major attack begins. Attack number 1. Make the microwave smarter. Companies such as Panasonic have been developing microwave systems that use multiple sensing points to monitor temperature and cooking condition. The idea is simple. The old microwave basically says, "You tell me how long." The smarter machine is trying to say, "I'll figure out how much heating this food actually needs." That sounds like a small upgrade. It isn't, because if the machine can measure what's happening, it doesn't have to rely entirely on fixed assumptions. It can adjust. It can compensate. It can cook more precisely. And suddenly that spinning glass plate starts looking like an unnecessary middleman. But Japan didn't stop there, because another company asked a much more radical question. What if we don't use microwave heating for everything at all? Attack number 2. Cook with liquid fire. This is where superheated steam enters the story. Normal steam sounds harmless. You think of boiling water. But superheated steam can reach temperatures far beyond ordinary boiling condition. And at those temperatures, it becomes a serious cooking medium. Sharp's Helio technology uses superheated steam to transfer heat rapidly, while maintaining moisture in food. That creates something a conventional microwave struggles to do. You can heat the inside, while also creating better browning and texture on the outside. And that's important because the microwave's biggest weakness isn't speed. It's quality. A microwave can make something hot incredibly quickly, but hot doesn't automatically mean crispy. It doesn't automatically mean browned, and it definitely doesn't automatically mean freshly cooked. Superheated steam attacks that weakness directly, but then comes an even stranger detail. The rule you've been told your whole life. You've probably heard this since childhood: never put metal in a microwave. Metal can cause sparks and dangerous electrical interactions inside conventional microwave cavities. But once you change the underlying heating method, you're no longer dealing with exactly the same problem. And that reveals something much bigger. The future of cooking doesn't necessarily involve making the microwave more powerful. It involves choosing the right physical process for the job. Microwave energy for one application, steam for another, sensors for another, and eventually, something that doesn't heat food at all. Attack number 3. Don't just cook it, restore it. There is another Japanese approach that focuses on something consumers notice immediately: texture. Some advanced steam-based appliances use a controlled burst of moisture before or during heating. The concept is simple. Instead of aggressively heating food and allowing it to dry out, introduce moisture as part of the process. Bread can become crisp on the outside while remaining soft inside. Previously refrigerated food can be reheated without becoming as dry. And leftovers can come closer to their original texture. Again, notice what's happening. Japan isn't trying to build one magical microwave replacement. It's attacking the reasons people tolerate microwaves in the first place. Speed, convenience, texture, moisture, consistency, one weakness at a time. But the fourth technology takes the story somewhere completely different. The technology that doesn't heat food. This is where things get strange. A Japanese technology called denba has been developed around an entirely different idea. What if you could influence the behavior of water inside food? When food freezes, ice crystals can form. Those crystals can damage cellular structures. Then, when the food thaws, moisture can escape. That's one reason frozen meat, seafood, and other foods can lose some of their original texture. But controlled electrical fields can potentially influence the freezing environment. Instead of simply accepting whatever happens when water freezes, the technology attempts to control the process. And that changes the size of the opportunity. Because now we're not talking about your kitchen. We're talking about seafood processors, meat suppliers, cold storage facilities, food manufacturers, shipping companies, supermarkets. And this is where the money gets interesting. The microwave was never the real market. Imagine you buy a better microwave. The manufacturer makes money from one appliance. Maybe you replace it again 10 years later. That's a consumer electronics business. But imagine you're a seafood company, shipping millions of dollars of frozen product around the world. If a technology can reduce moisture loss, preserve texture, reduce waste, or improve the quality of food after transportation, the value of that technology isn't measured in dollars saved on one dinner. It's measured across an entire supply chain. That's a much bigger market. And this is the pattern hiding behind all four technologies. The consumer sees an appliance. The companies see something much larger. Sensors, heating system, steam technology, electrical field technology, industrial food processing, cold chain logistics. The kitchen is simply where consumers first notice the technology. And then comes the bigger threat. But there is one more technology that could eventually change microwave heating at its deepest level. Solid-state RF. Traditional microwave ovens rely on magnetrons. Solid-state RF uses semiconductor-based electronics to generate and control electromagnetic energy. And semiconductors offer something extremely valuable: precision. Instead of simply generating microwave energy and letting it bounce around inside a cavity, future systems can potentially control energy delivery far more precisely. That means the microwave could eventually stop behaving like a crude box that blasts energy into food, and start behaving more like a computer-controlled heating system. And that's where the business model becomes particularly interesting, because the winner doesn't necessarily have to sell the finished appliance. It could sell the technology inside it: sensors, semiconductors, RF modules, control systems, software, patents, licensing, industrial equipment. One technology provider could potentially supply its technology to many appliance manufacturers and industrial customers. And that's a completely different business. You buy one microwave. A manufacturer might buy millions of components. The microwave won't die in one day, and that's why I don't think the microwave will suddenly disappear. Cheap microwaves will still exist. They're convenient. They're affordable and they work. But that's not how technologies usually become obsolete. The landline didn't disappear because the world announced, the landline is now dead. People simply found better alternatives. The same thing could happen here. First, smarter reheating. Then better cooking. Then better texture. Then better freezing. Then better food preservation. Then industrial applications. One use case at a time. Until eventually the microwave isn't the default anymore. It's simply the old option. The real billion-dollar trick. And this is the part I think most people miss. The story isn't really about killing the microwave. It's about removing the compromises that made the microwave necessary. The microwave gave us speed, but we sacrificed texture. It gave us convenience, but we accepted uneven heating. It gave us long-term food storage, but freezing could damage quality. Now different technologies are attacking each compromise separately. Sensors can measure. Software can decide. Steam can cook. Controlled electrical fields can influence freezing. And semiconductor technology can make electromagnetic heating more precise. Put all of that together, and the biggest opportunity isn't necessarily the company that builds the next famous kitchen appliance. It could be the company that owns the technology layer underneath the entire food system. The full circle ending, and that brings us back to the spinning glass plate. For decades, we thought it was simply part of the microwave. But now you know what it really represents. A compromise. Instead of perfectly controlling the energy, we moved the food. Instead of perfectly controlling texture, we accepted whatever came out. Instead of controlling freezing, we accepted ice crystals and moisture loss. For 80 years, we got used to those compromises because the microwave was fast. But now, for the first time, technology is becoming good enough to attack the compromises themselves. And one day, your kids might look at a microwave, sitting in an old kitchen, watch that glass plate spinning, and ask, why did the food have to spin? And you'll be able to tell them because for almost 80 years, that was the easiest way to work around a problem. Until Japan started asking a much better question. What if we stop working around the problem, and actually control it? And that's when the microwave replacement stops being a kitchen story. It becomes a multi-billion-dollar technology race.